Hello, good morning or good afternoon to everyone. This is Clemens Simler speaking. I am a member of the board of the Java Code Forum, and it's a pleasure to me to welcome you to our third webinar in this year's webinar series. Today we have Francesca Forestieri of GlobalPlatform. She will present how the standardization of secure elements supports security in software-defined vehicles. JavaCard's secure elements are the main platform to secure yearly billions of devices in different market segments, such as telecommunication, payment, identity documents, or access control. Automotive is increasingly taking advantage of these secure elements and benefit the same level of security than these markets. Requirements and needs for security have dramatically increased within the automotive industry with drivers such as connected vehicles, electric vehicles charging, autonomous or assisted driving, and software-defined vehicles. Francesca is GlobalPlatform's automotive lead and is responsible for connecting the automotive value chain with experts on trusted digital services to address the latest developments in the automotive ecosystem and work to future-proof connected services. She was previously the automotive director of the Connected Living program at the GSMA. As usual, the webinar will be recorded and available in our YouTube channel so that you can focus on the presentation now. There is a chat feature in the webinar where you can ask questions on the fly, as the microphones are muted during the presentation. You will also be able to ask your questions to Francesca directly at the end of the presentation when we will open the microphones. And now, Francesca, the floor is yours.
Thank you so much. Thank you everyone for coming. I'm quite excited to talk about our topic around software-defined vehicles and how secure elements are part of supporting security and the importance of standardization. So let me start. For those of you who are not familiar with GlobalPlatform, it was created around 20 years ago for secure chip technology, and it began in the financial industry, but it has covered a number of industries, including the mobile industry, and most recently, an automotive industry. We are a very present technology, as you are probably aware. Our GlobalPlatform specifications have resulted in 60 billion secure elements shipped worldwide this year. And our specifications are available freely on our website on a royalty-free basis. Our members also are, not surprisingly, many semiconductor organizations, but we also have IP organizations, we have governments, we have labs, and they really cover the full value chain. And we have also started to see a pickup in automotive organizations joining. In fact, Cariad is the software development group for VW, and they are a member as well as Analog Devices, which are two examples of specific automotive members. But in reality, our members are in general all present in the automotive market, which is one of the reasons why this initiative began. So GlobalPlatform believes very strongly in leveraging industry, regional, international standards organizations in order to provide solutions, so not to start from scratch. And with that as a basis, we work closely with the Society for Automotive Engineers, Car Connectivity Consortium, AUTOSAR, in specifically the automotive market, but also ISO-SAN, ETSI, GSMA, GCF, et cetera, et cetera. Our belief is that working together, we can focus on delivering interoperability as well as innovative digital services. So just an example of our collaborative partners, and you can see that quite a few, even if they are not directly automotive only, are still quite relevant. And it's about 50% of our collaborative partners. And once again, it's a little bit like the membership in the sense that automotive has become more and more important in these different domains. So in terms of market presence in automotive, because of the EUICC being based on global platform specifications, it really means that all connected vehicles are using a secure element. And other use cases for the secure element include digital key, electrical vehicle charging, and key management, but there are many others. On the right-hand side, we also have other technologies, such as a trusted execution environment, and other use cases, but in reality, the use cases are not so discrete in the sense that we see overlap between both secure element and trusted execution environment. And in some cases, they are deployed jointly. So why is automotive becoming so concentrated on security? Essentially, the United Nations passed UNECE R155 and 156, which was applicable in July 2022, and for all vehicles as of July 2024. And it is applicable in over, I think, 70 countries, which are the green ones. Associated to that, we have a standard from ISO SAE, which is the 21434 and the 24089, which are ways to demonstrate compliance. It's not the only way, but it is the standardized way. And as you can see, the US is not part of that, is not part of the UNECE regulation, but the standard is being used also in North America. Even though the UNECE, even though the UNECE has not, sorry, I need to go back. All right, well, okay, sorry, here we go. So I just wanted to say that the UNECE is very clear about showing a process of what needs to happen, but it doesn't really explain how those security standards for automotive need to be realized. In addition to these two regulations that I've mentioned, there are many other areas of regulation within automotive. Some of them are right to repair, privacy, national and EU cybersecurity acts, post-quantum cryptography, and the Red Directive in Europe. But there are many others. And all of these things have come to put a magnifying glass on the importance of cybersecurity. So as I mentioned earlier, cybersecurity management systems for UNECE 155 is essentially a process within the OEM to demonstrate that they have paid appropriate attention to cybersecurity. What's very relevant about this is the fact that for the first time, the OEM is actually responsible for the compliance process. In the past, it has not been so directly tied to them, in the sense that they would provide requirements, they would ask their suppliers to provide security, but it was pretty much in the hands of the first or second tier suppliers. And this has been a massive change in terms of the way the industry works. UNECE 156, on the other hand, focuses on the software update management system, so over-the-air updates. And this maintains the onus for the OEM, but it also has a portion of that with regards to the supplier. In both cases, though, there are process-based regulations. In order to respond to those regulations, there are ISO standards, as we mentioned, 21434 for UNECE 155 and 24089 for 156. But there are actually quite a few other standards bodies that have also standards related to cybersecurity. And in fact, before the UNECE publication, there really were no direct automotive cybersecurity standards, but there was many different pieces, some that came from IT and others that did not. But in any case, ETSI, ISO, and SAE International all have different standards around cybersecurity. And one that we will be talking about further is the SAE J3101, which is looking at the hardware protected security environments for ground vehicles. So why is there such a security challenge? The vehicles have become more and more connected, and obviously that means that there are more attack surfaces. There are non-cellular communication that's happening, including vehicle to infrastructure, vehicle to vehicle, GPS, NFC, Bluetooth, and USBs. But there's also cellular connectivity. And all the associated back-end systems, the data, and over-the-air updates. This really has resulted in the need for a dramatic change in paradigm for security. One thing, Upstream did a report this year for 2023 showing where the current cybersecurity trends and threats had occurred. And you'll see that the telematics and application services are the highest, for instance. But in reality, I think what's most interesting about this is not the percentage points, because I believe that has more to do with the fleet that's out there connected and which services are actually available, but the fact that there is really a multitude of different attack channels. And this is something that's really new for automotive. So in order to look at what kinds of needs for security there are in automotive, a big focus is on flexibility. So there needs to be the possibility for multiple security services. In the past, there's really been a focus on key stores within the vehicle, but we're seeing more and more services being deployed and being planned for within the vehicle that would require security support. The ability to update services over time, not only in terms of once during the car lifetime, but new services, regular updates. So they could even be as frequent as what we're seeing in phones. That's a really huge difference. And the idea of being able to develop new services after the car has been deployed, given that many vehicles have a lifetime of more than 10 years, is a very potent challenge for the automotive market. The idea of multi-tenant security services, so that there can be frenemies on the same platform, offering different security services and ensured isolation between that. So if you look at today's market with bank cards or with your cell phone with banking applications, certainly there has to be complete isolation and no leakage between the two. And this is what we see happening in automotive, and it's expected to only grow. Also, the chip shortage in automotive changed many OEMs' outlook with regards to their relationships with vendors. And there is a demand from many to have a portability of services for common security requirements. That's not to say that there wouldn't be differentiators, but that there would be a common baseline set of security requirements that would allow for second sourcing solutions. This is something that would have made life very different, for instance, for Stellantis or GM during the semiconductor crisis, but not only. And the fact that using standardized security solutions has a very foundation benefit because of the fact that the industry comes together in terms of the development of the specifications, and it's not left to a sole proprietary security solution. It's not that a proprietary solution in of itself is not secure, but the fact that there are more industry experts coming together to develop those specifications, it's more eyes on the same problem to try to make sure that it's robust. Also, it's the ability to provide integration into existing ecosystems. So once again, with proprietary solutions, there is everything has to be done for that solution. But given GlobalPlatform and Java cards already existing ecosystem, there is the ability for these solutions to leverage those resources and also the skill sets supporting them. So if we look at the market forecast for automotive, no matter who you look at, it's very large, and it's one of the largest areas of growth that's being considered. There is some differences of opinion with regards to which geography will be the largest. But for instance, in this case, they're talking about APAC. But what is clear across every forecast is the presence of automotive being a growth sector. Oops, that's there. So let's talk about GlobalPlatform technologies. GlobalPlatform has the secure element, which is a secure enclave protected against physical and software attack. It runs on an embedded Java card operating system and provides standard APIs and functions. You are, I'm sure, quite familiar with the fact that it's in SIM cards, passports, bank cards, and embedded applications. And it also supports multiple independent applications or containers. One of the things that we believe is very, very important in terms of the approach to security with GlobalPlatform is the existence of protection profiles. These protection profiles are set by GlobalPlatform, the specific security objectives for the products. Then GP defines the implementation requirements. Third-party accredited labs evaluate the product according to those, to that profile. And the protection profile is published publicly. And therefore, that supports the idea that there is transparency around what is being declared in terms of security robustness. Traditionally, GlobalPlatform has worked with common criteria, but we now have a new security evaluation methodology, which is also possible for certification, called CESIP, and it will become a European standard next year, 2024. The main difference is that it is a somewhat more intuitive approach to certification. You don't have to be a security expert, but it's based on the same principles with common criteria, and it does support the use of protection profiles. So if we look at GlobalPlatform secure element, it leverages the Java card protection profile, and the secure elements protection profile is on top of that. And then outside of that are any number of applications related to the industry. And this combination together, or marriage of sorts, has really supported the deployment globally with incredible numbers in terms of ID cards and embedded secure elements. The secure element protection profile is modular, so it extends the Java card protection profile with regards to the security problem, the objectives, and the requirements. And our protection profile is standardized for evaluation with regards to the assets, the threats, the security objectives, and the requirements of the card content management. There are an additional 4 modules that are referred to as amendments regarding to confidential card content management, contactless services, executive load file upgrade, and management services. So what are we doing in GlobalPlatform with regards to automotive? The first thing that we have focused on has been developing what we call the Cybersecurity Vehicle Forum. And we started last year in November with the goal of having 1 event per region, 1 in Europe, 1 in the US, and 1 in Japan and China per year, in order to invite people from the extended automotive value chain to identify where they felt the biggest priorities and challenges regarding secured components existed for automotive. And this has been quite an interesting discussion point. And what comes out of the Cybersecurity Vehicle Forum then feeds into the Automotive Task Force. It has resulted in the development of white papers, but it also feeds into the Security Task Force and the Regional Task Force, so for China and Japan, for instance. And together, these all feed into our technical committees that are responsible for specifications and protection profiles. So this process is designed to help us better support the specifics of the automotive market. When we look at the first Cybersecurity Vehicle Forum that was held, we did some whiteboarding together, and 35 use cases were reviewed. Of those, 22 were considered relevant, and 6 were really the lowest hanging fruit. So we did this analysis within the Automotive Task Force internally with members, and then we launched the first work items, which focused on what we could do in terms of standards alignment, and that essentially focused on developing a relationship with SAE International, specifically around the hardware protected security environments, as well as AUTOSAR, and providing additional information around trust anchors and guidelines on how to use them and sort of what the definitions are for GlobalPlatform. So we have 2 white papers that are available publicly within our resources section on the website. The most recent one was just published last month on trust and security in the automotive systems. We have a vision about trying to secure software-defined vehicles because we think that's something that is easy for the industry to understand, and that no matter how software-defined vehicles are, there will always be a hardware element. So we have started with the mapping of the GlobalPlatform specifications to automotive standards. With regards to SAE, it's this J3101. I'll talk a little bit more about it. We have also begun discussions with AUTOSAR about what we can do to make sure we have compliance with what they're currently doing. And the additional support is to demonstrate and support the certification for automotive in the UNEC regulations around cybersecurity. There is no direct requirement for certification of components, but OEMs are responsible for generating or adhering to best practice and showing due diligence in best practices around cybersecurity. We believe certification, in particular CESIP certification, can be a means to generate artifacts for those regulations. Also, there is the opportunity to look at any outstanding requirements, including, for instance, trusted service domains. And I'll explain that a little bit more. But essentially, when we look at the mapping for the hardware protected service environments, there is a almost one-to-one alignment with the difference that we have much more detailed guidelines than the SAE recommended best practice, but a good portion of those requirements are left to the client to develop as they wish. And because there are a series of things associated to a key store that are specific to automotive and seem to be a common security requirement, there's discussions about what the best way is to support that. And then what all that means is that we're looking to develop an automotive configuration within GlobalPlatform for the secure element for MCU. And we're discussing the utility of creating test suites specifically for the automotive. It is something that SAE has indicated they would be very, very interested in. Once we have this automotive configuration, we're looking at trying to extend that regionally, and we have started discussions in Japan and China around that, and also to extend our technical alignments. And I'll talk a little bit more about that in a moment. So in terms of the organizations that we are currently discussing with, on the top row, you see who we have established. We have MOUs with them, including RISC-V. We are also in discussions with China SAE, JASPAR, and the Autonomous Vehicle Computing Consortium on how we can best cooperate. All of this relates to this automotive configuration that I mentioned earlier. So let's talk about a little bit more of the details around the J3101 and the hardware protected security environments. So as I mentioned, the UNAC regulations really only mandate a process. We have been told by SAE that initially the idea was that there would be two publications of standards to support the UNAC 155. One would be the 21434 around the process, and the second would be around the product. And that together they would demonstrate the cybersecurity vehicle management compliance. In reality, there were delays, and the SAE J3101 was only published in 2020, and therefore the reference to the UNAC 155 does not exist. But the way SAE looks at it is that these are the two components of how to bring together compliance. This particular standard is a recommended best practice in reality, and it has been based on 3 application use cases. They are fairly general, and in terms of their requirements in the standard. So even though it's IPR protection, secure diagnosis at the ECU level, and secure logging, in reality, the parts of the requirement that are addressed are the definition of base confidentiality, base integrity, and access control, as an example. So it's not the full scope of the use case. What is interesting is that this requirement, as they say, recommended practice, is something that was developed to support the idea that there would be a common means of describing and comparing products from different vendors, given that in the past everything had been based on proprietary solutions, but people referred to them with more or less the same names. So HSM, She++, things like that. So with regards to GlobalPlatform's work and the mapping, 65% of protection profiles for common, for the secure element directly address and exceed what J3101 is asking for. This 32% is something which is also 100% addressed, I put in quotes, given that they are elements that are regularly supported under the domain of the trusted application or applets running on secure element or the TE. But they have been left in the hands of the client. So the global platform solution in itself supports all of the requirements, but the way Global Platform looks at the universe is part is the platform, which we work on, and a part is what the client develops. There is a 3%, which is mostly associated to the trusted execution environment and about the hardware isolation, which is not 100% covered. But so you can see that Global Platform provides a very good coverage of the requirements for J3101. The question is whether the 32% should be something that is standardized or not. So the first steps are really quite clear. As mentioned, we have done this analysis on the J3101, and we have determined that, in fact, using Global Platform specifications for secure elements does meet J3101. And in our discussions with SAE, they have, just as of 2 weeks ago, have declared that they are unanimous in determining that there is, that they want to publicize, to promote the version 2 with this mapping of our technologies. The things that we still need to discuss and decide on are the APIs and profiles. Do we really want to be having a standardized successor to the Sheet++, HSM, and Avita? And looking at, if there's enough common requirements around key usage. So Global Platform focuses really on general purpose compute and containerized functions associated to that. But a part of that is this security containerized platform, and potentially a piece of that containerized function could be the key store. What we have been working on promoting, understanding around in the automotive industry is the fact that it's not just the key store that Global Platform solutions support, but that the multi-tenant security services can all be supported by Global Platform technology. And in terms of the safety critical areas or special purpose embedded MCUs or artificial intelligence, those are areas which Global Platform does not currently work, but that doesn't mean that they couldn't. It's a question of really where the demand is. So our focus right now is on our more core business around general purpose compute. One of the things that is interesting regarding the evolution path for security critical use cases is that in the very beginning, quote unquote, 10 years ago maybe, the connected car use cases were somewhat limited. But the vision of where it could go with software-defined vehicle use cases and the diversification of services across the value chain really creates a demand for a completely different paradigm, as I mentioned earlier, that are requiring from automotive manufacturers a very different approach. So get involved. Why we think security standardization is important versus a solely proprietary solution is because we believe it helps to support an effective cybersecurity practices. This allows us to have transparency on security approaches. It means that standards are not just developed in an obscure manner or and are not verified across the industry, and that their regional requirements are addressed, so they don't have to be done individually. The evidence of compliance, we believe, is a very, very important part of why Global Platform technologies have been and solutions have been adopted globally. And that is in terms of security certification and functional compliance. And although these are things that have typically been not, let's say, almost bad words in terms of automotive. It's something that is being seen by some OEMs as a way for them to demonstrate their due diligence, best practice adoption, and help to support their position in compliance with the regulatory requirements. Also, having a security standardization also allows for timely, effective cybersecurity responses. So the fact that there's a community behind the analysis of threats, that there's transparency around the responses and coordinated responses, and also that the evolution of the platform is happening in response to the trends and attacks and threats, as opposed to relying on a single organization. In addition, we believe it contributes to optimized products in terms of there being a lower cost for mass market produced solutions. Now, in this part, we're talking about the costs associated to the common security features depreciating across the community. That doesn't mean that we don't think there's differentiators, but that this allows for more money to be focused on engineering of those differentiators and less on the aspects that are not currently providing a competitive advantage. And the benefit of this is that even though there should be, let's say, less cost, it's still incorporating greater sophistication on the cybersecurity solutions that have been employed in automotive in the past. GlobalPlatform and JavaCard have certainly a baseline of addressing security standards and multiple tag services in a way that automotive has not been in the past experienced with. There's also the possibility of second source options, which would be very important for what has happened with the semiconductor chip shortage and reduction of integration costs from simplified ECU development, in that the new ECU generations would have a portability for common services. And last but not least, that the ecosystem, which I mentioned a little bit earlier, is already quite rich in terms of multiple skilled stakeholders. And that means that the OEMs and the tier ones or tier twos don't have to rely solely on who they have in-house, and that there is international coverage of multiple markets. So how does this come together? We believe what we're currently working on is this global platform automotive configuration, which the first step really is associated to the SAE with regards to the hardware protected security environment. We are working with AUTOSAR, as I mentioned, in terms of compatibility with the different platforms and how they can demonstrate best practices around hardware protected security environments. We are currently working with the security working group within AUTOSAR, but have just recently determined together that we will also be engaging with the system test working group and the UCM for OTA. We are still in the phase of defining exactly where the best touch points are for cooperation, but there is a belief on both sides that it's important. And our goal is that this automotive configuration would ensure compatibility. And as I mentioned, we're looking at trying to make sure that this is regionally relevant, and we are in discussions with JASPAR, AUTOSAR, and within China on the National Innovation Center for Vehicles, China SAE. And we're looking at extending technical alignments with PSA, the Autonomous Vehicle Computing Consortium. We already have a RISC-V agreement, but we're looking at whether there may be work items around automotive, and also the Car Connectivity Consortium, which we have an existing MOU, but we're looking to see if there's anything that may be useful for additional cooperation. So I mentioned how GlobalPlatform works in general, but I think what's important is that you can see how our technical committees here from the Secure Element and the SESA committee, which is a new committee, for instance, are working with the external world in terms of vendors, open source, ecosystem, and labs in ensuring that these specifications and protection profiles are addressing the industry needs. The Cybersecurity Vehicle Forum, which is this platform, which is free for non-members currently, and invites at a regional level participants across the full value chain, normally has around 70 to 100 average participants. We had one last week in Hamburg, and within the automotive task force within GP, so for members, we have 49 companies currently participating. So join us. Certainly you can follow global platform specifications, which are publicly available. But if you become a member, it will help to optimize your roadmap as you have early visibility on specifications. But most importantly, if you're interested in automotive, come and contribute on the development of these specifications, both in regards to the existing topics, as well as if there are new topics that you'd like to bring to the table. So thank you very much. And that's it from me. Are there any questions?
So thank you, Francesca. And I think, yes, in the chat, we have some questions for you, starting with the first one. So Java Card offers a certain level of portability of the Java applet across different SE implementation, along to the capability of loading different applet on the same secure element. Do you see the automotive market could benefit from or seeking such features? So do you see multi-applet configurations in the automotive area?
Yes, that's exactly what we're talking about with them. And when I was mentioning the fact that they need, if I go back to, sorry, this is here, the green part on the security containerized platform. For us, those would be the possibility for either new applets on the same SE, or in some cases it would also be TEs, but we see it, we see the demand in multiple domains, including V2X for the SE.
Okay, thank you. And then there is a second question. Do you see Java Card playing a role as RUICC or also as ESE? I'm concerned that automotive use cases might require a higher performance in comparison to usual Java Card use case.
So certainly that's a hot topic. One of the things that the way we're seeing things evolve in automotive is that they have really, right now they have chips for many, many different things with very, very different performance requirements. So in and of itself, there isn't a reason why the performance requirements would, for some functions, would fit well with the UICC or the E secure element. We also see in automotive that in some cases they are deploying both secure elements as well as trusted execution environments for different security services. So when we look at software-defined vehicles, certainly there's a whole lot of discussion on very large, high-performance use cases, but there are still quite a few applications which have lower performance requirements and are supported by SEs and can continue to be supported by SEs or together with TEs, depending on the application.
Okay, thank you. So it was a yes and no. Sometimes it's challenging
Yes.
In other use cases, it's okay. And yeah, let's see then what the future will show us. Yeah. Then is there a further question? No, I don't see any further question. Seems we have covered all. So is there someone who wants to directly ask Francesca a question? No? So then I think we are done for today. I would like to thank you, Francesca. Thanks for giving us this great overview on the standardization in the automotive area and the advantages of going to a highly standardized area like GlobalPlatform here. Gives really a good overview. Thanks for that. And I would like to welcome all of you, of course, in one of our next webinars. There are some still to come. So thanks for joining today in this webinar and hope to see you soon in one of our next sessions. Thank you and have a nice day and have a nice evening.
Thank you very much.
Thank you.
Appreciate the opportunity.
Bye. Bye.
Bye-bye.